Code readability and maintainability are essential aspects of software development that play a crucial role in the overall quality of the codebase. Well-written code not only makes it easier for developers to understand and work with the code, but also ensures that the code can be easily maintained and updated in the future. In this tutorial, we will explore some best practices and next steps for achieving code readability and maintainability. 1. Use clear and descriptive names. Choosing meaningful and descriptive names for variables, functions, classes, and other code elements is a fundamental aspect of code readability. Aim to use self-explanatory names that accurately convey the purpose and functionality of the corresponding element. Avoid using vague or generic names that may cause confusion. 2. Keep code blocks short and focused. Breaking down complex logic into smaller, self-contained code blocks improves code readability. Each function or method should have a clear and single responsibility, making it easier to understand and maintain. Use meaningful comments to provide additional context or explanations where necessary. 3. Follow consistent formatting and indentation. Consistency in code formatting and indentation helps in improving both readability and maintainability. Adhere to a specific code style guide or set of conventions consistently throughout the codebase. Tools like linters and code formatters can automatically enforce these conventions, making it easier to maintain consistency. 4. Write modular and reusable code. Code modularity and reusability are crucial for maintainability. Break down the code into smaller, reusable modules or functions that can be easily understood and maintained independently. Encapsulate related code within classes and modules, applying the principles of object-oriented programming to promote reusability. Minimize code duplication. Code duplication not only adds unnecessary complexity, but also makes it harder to maintain the codebase. Identify common patterns and functions that are repeated throughout the code and encapsulate them into reusable functions or classes. This reduces redundancy and makes code maintenance more manageable. 6. Write comprehensive and clear documentation. Documentation plays a vital role in maintaining code. Document code functions, classes, modules, and any significant implementation details. A well-documented codebase helps new developers understand the code quickly and facilitates maintenance and updates in the future. Use tools like Javadoc, Doxygen, or Markdown to generate documentation from code comments. As you continue your journey in programming, it's important to explore further resources and consider potential career paths. By doing so, you can enhance your skills, gain new knowledge, and make informed decisions about your professional development. In this tutorial, we will provide you with guidance on how to explore further resources and highlight different career paths in programming. Let's dive in. Online learning platforms offer a wide range of courses and tutorials to help you build new programming skills or deepen existing ones. Websites like Coursera, Udemy, and edX provide high-quality programming courses taught by industry professionals. Take advantage of these platforms to explore different programming languages, frameworks, or specific areas of interest like AI, web development, mobile app development, or data science. Contributing to open-source projects is an excellent way to gain practical experience, collaborate with experienced developers, and improve your coding skills. Websites like GitHub and GitLab host countless open-source projects covering various programming languages and domains. Find projects that align with your interests, contribute to them, and engage with the community. This not only enhances your programming abilities, but also serves as a valuable addition to your portfolio. Joining online communities and forums dedicated to programming can help you connect with like-minded individuals, share knowledge, and seek guidance. Websites like Stack Overflow, Reddit, and Hacker News are vibrant communities where programmers exchange ideas and help each other. Participating in discussions, asking and answering questions, and being an active member can contribute to your growth as a programmer. Building your professional network is crucial in any field, including programming. Attend local meetups, conferences, and workshops related to programming to meet professionals and gain industry insights. Engage in conversations, share ideas, and make connections with individuals who can provide mentorship, job opportunities, or simply broaden your understanding of the programming industry. There are many programming blogs and podcasts available that provide valuable insights, updates, and tutorials on various programming languages, tools, and frameworks. Follow influential bloggers to stay updated with the latest trends, tips, and tricks in the programming world. Listening to podcasts during your commute or reading blog articles during your free time can help you stay informed and inspired. While exploring further resources, it's essential to consider different career paths within programming. Programming is a versatile field with numerous career options. Here are a few popular career paths. Web development. Build websites and web applications using HTML, CSS, and JavaScript, along with frameworks like React, Angular, or Django. Mobile app development. Develop mobile applications for iOS or Android platforms using Swift, Java, Kotlin, or React Native. Data science. Analyze and interpret large datasets using Python, R, or SQL, and leverage machine learning algorithms to extract insights. Software engineering. Develop software applications or systems using various programming languages like Java, C++, or C#. In the world of programming, testing and debugging play a vital role in ensuring the quality and reliability of software applications. By employing effective testing and debugging techniques, programmers can identify and address issues that may arise during the development process. This tutorial will explore some of the best practices and next steps related to testing and debugging. Test-driven development. TDD test-driven development is a software development approach that emphasizes writing tests before writing the actual code. It follows a simple cycle of red-green refactor, where tests are written to initially fail red. Then the code is written to pass those tests green. And finally, the code is refactored to improve its quality while the tests still pass. TDD helps ensure that the code is testable, maintainable, and bug-free. Test coverage. Test coverage refers to the extent to which a software system has been tested. It is important to aim for higher test coverage to ensure that most, if not all, parts of the code have been exercised during testing. Tools such as code coverage analyzers can help in measuring the percentage of code covered by the tests. Unit testing. Unit testing involves testing individual units or components of the code in isolation. It aims to identify defects in specific functions or methods by creating and running small tests that target those specific areas. Unit testing frameworks like JUnit for Java or PyTest for Python can be employed to automate the testing process. Integration testing. Integration testing involves testing how different units and components of an application work together. It aims to uncover issues that may arise when different modules interact, such as data inconsistencies, communication problems, or incorrect behavior caused by integration issues. Frameworks like Selenium or Cypress can be used to automate integration testing for web applications. System testing. System testing verifies that the software system meets its requirements and functions as expected in a real-world environment. It focuses on testing the entire system as a whole, including all integrated components. Techniques like test scenarios, acceptance testing, and black box testing can be employed to validate the system's functionality. Debugging techniques. Debugging is the process of identifying, analyzing, and fixing bugs or problems in the code. Here are some common debugging techniques that can help in the process. Log statements. Adding log statements in the code can help track the execution flow and identify potential issues. Log levels can be adjusted to increase or decrease the amount of information captured during runtime. Step-by-step debugging. Debuggers provided by integrated development environments, IDEs, allow developers to execute the code line by line, observe variable values, and identify where the problem occurs. Breakpoints can be set to pause the execution at specific locations, making it easier to inspect the state of the program. Understanding the importance of version control in software development is crucial. One popular version control system is Git, which allows developers to track changes made to their code over time. In this tutorial, we will explore the best practices and next steps for using Git effectively. Let's dive in. To start using Git, you need to initialize a repository. Open your terminal and navigate to your project directory. Use the following command to initialize the repository: git init. Branches provide a way to work on different features or bug fixes without affecting the main codebase. Create a new branch using the following command: git branch feature branch. Switch to the new branch by executing git checkout feature branch. Make your modifications, commit them, and push them to the remote repository. Once done, you can merge the branch back to the main branch using the following commands: git checkout main, git merge feature branch. Merge conflicts occur when Git detects conflicting changes in different branches. These conflicts need to be resolved manually. To resolve a merge conflict, open the conflicted file and locate the conflicting sections. Make the necessary changes, save the file, and commit the changes. After resolving all conflicts, Git lets you proceed with the merge. Tags are used to mark important points in the project's history, such as releases or major milestones. Create a new tag using the following command: git tag v1.0. You can push the tags to the remote repository using git push tags. Git enables developers to work collaboratively on a project. You can clone an existing repository using git clone repository URL. To fetch updates from the remote repository, execute the following command: git fetch. Merge the fetch changes into your branch using git merge origin/main. Push your local changes to the remote repository, git push. Git allows you to undo changes using several techniques. To discard changes made to a file since the last commit, use git checkout file.txt. To undo the last commit and discard its changes, execute git reset softhead1. If you want to revert a specific commit while keeping the changes in the commit history, use git revert commit hash. This command will create a new commit that undoes the changes made in the specified commit. A common Git workflow is the feature branch workflow. It involves creating a branch for each new feature, bug fix, or improvement. The workflow typically consists of the following steps. Create a new branch for the task. Make changes and commit them. Push the branch to the remote repository. Open a pull request for code review. Merge the branch to the main branch after the review. Delete the feature branch once it's merged. Familiarize yourself with additional Git commands such as git log, git stash, and git rebase. Look into Git GUIs like SourceTree and Git Kraken to simplify Git usage with visual interfaces. Learn about Git hooks to automate tasks or enforce guidelines. Explore continuous integration/continuous deployment (CI/CD) tools like Jenkins or Travis CI, which can work seamlessly with Git repositories. Remember to regularly update your Git knowledge by reading documentation and following Git-related resources like tutorials, blogs, and webinars. Following these best practices and moving forward with Git will help you effectively manage your projects, collaborate with other developers, and ensure the stability and reliability of your software.